All right, so today we are transforming polynomial functions, and our essential question is, how do I transform polynomial functions? Easy enough.
Yeah, we have
We've done stuff
learned
like this
transformations a ton. This should not be hard at all. So why do we learn this? Well, transformations can be used in business to model sales. Pretty cool, huh? You can perform the same transformations on polynomial functions that you performed on quadratic and linear functions. Same thing.
It's kind of a review.
Right. So here's the table that we're very familiar with. We're not gonna read through it, but there's all different types of transformations. The only thing I want to mention is we do vertical, horizontal, vertical stretch compression, and reflection. The one thing we don't do is we don't do a horizontal stretch or a horizontal compression.
Okay.
So that's the one now we're going to move on to the next page because I think we're done with that page. And I'm going to try to move on to the next page. And example 1 tells you the function f of x equals x cubed minus 6. Write the rule for each function and sketch its graph. So we were very kind to you. We sketched the graphs ahead of time. So we're given the f of x function, and we have to create a new function, g of x. So Miss Boyd, would you do me a huge favor and draw a box around?
This is our original.
Yes, got it. Blue is original, and then the red is going to be the new. Okay. Would you put a box around f of x right there? Perfect.
Just f of x, or
yeah,
f of x minus 2?
Just f of x.
Got it.
Because what I like to do, and then maybe put a box around what f of x,
what it equals.
Right.
I got you.
Because what I try to tell students then is what's going to go into that f of x box is x cubed minus 6.
Okay.
So can you do that, please?
Yes. So g of x equals.
I do parentheses, yeah.
Me too. Minus 6
minus 2. That's it. And now we can combine like terms because a negative 6 minus 2 is a negative 8. So you end up with x cubed.
We don't even need parentheses anymore, right?
No, we don't.
All right. So we have x cubed
minus 8. And then maybe write g of x because that's, you just created the new rule equals that. And that's it. So what it's saying is when the minus 2 is outside, that means it's going down 2. So maybe down below, oh, there you go, or there, moves down 2 units, right?
And that's what happened. It moved down 2 units.
That's it, right? So let's go on and let's look at example number 2. It's giving the function f of x. It says write the rule for each function and sketch its graph. Okay. So now notice it's a little bit, it is a little bit different because as you notice, the new function is something it's changing in the parentheses. Inside. Whereas I'm going to scroll up, here we had our change happening outside. That's a vertical up or down move. When something is changing in the parentheses like that, that means you have a horizontal move. And it's going to be 3 units to the left. Because it's opposite. It's always opposite. So now what we're going to do on this one is the x plus 3 is going to go into x up above. So that's where students, they really struggle with this. So we write
x plus 3
cubed minus 6. That whole thing is equal to, maybe write g of x. And I don't make students expand out the x plus 3 times and FOIL and multiply because we've already assessed you on that. I want to know, we want to know, do you know how to create a new function? And that's what you just did.
You know how to plug it in.
You know how to plug it in, right. Perfect. So we move 3 units to the left, and if you look at the graph, that's exactly what's happening. We're moving 3 units to the left.
Perfect.
Okay. Next page is, I'm just trying to find my mouse. There it is, the next page. Oh, yep, I went there. Okay. Now here's another function. Write a function g that performs the transformation. So now before, they didn't give us words. Remember before? If I go back a screen so we can I like to do a comparison here. on these, we said g of x is equal to, and they told us
Gotcha.
what it's going to be.
Mhm.
Here, they're writing it in words. So,
so it's gonna reflect
reflecting
across.
across. So I'm going to unlock this for a minute because we're going to need that. So we're reflecting across the x-axis. So what that means is the graph's going to flip upside down.
Right, because of this negative.
Right, so let's first create our new function.
So all of this
Is f
gonna
of x.
go right here now. So we have g of x equals
And then a minus,
negative,
and then in
plug it all
parentheses
in.
is x cubed
plus 5x
Yep.
squared
minus
minus 8x
plus 1.
We didn't add or subtract anything on the inside. We didn't add or subtract anything on the outside. The only thing that changed was this negative, which means it flips.
Right.
So-
Now, I do want them to distribute the negative, though, inside.
right.
I do want to do that extra little step.
So we will get g of x equals negative x cubed minus 5x squared plus 8x
Right.
minus 1.
And that's exactly right.
Okay.
That is the new function. So now,
if we want to look at it,
flipped across, we go into format, and we go into flip.
oh, is it unlocked?
Oh,
Hold on. I think we're
oh,
good.
you
We
have to
just didn't
click
have
it
There we go.
up and down.
So we click it, it flips.
Oh, it did what I wanted it to
and
do.
It flips perfectly. Look
Okay.
at that.
It
flipped
didn't work when
right
we were
across the
practicing.
x-axis.
Yes, and that's exactly what the graph should look like. So in your
Nice.
notes, that's what you should do.
So we'll go back so you can see it full screen. Oh,
Okay.
just kidding.
Do you want me to do that?
I got it. I just hit the wrong guy.
Okay.
There we go. There we go.
And that's what it should look like.
Nice.
Flipped right over the x-axis.
Perfect.
All right, now number 4, I think that one we're reflecting across the y-axis. Do we want to wait for that one and do that one in class? Or I have
Probably.
2 of those actually, I'm thinking. Maybe we should do this one.
Okay.
Let's do this because it's different.
Sure.
It's that one was reflecting across the x-axis. Now we're reflecting across the y-axis. So notice the difference here. If you go up
Yeah.
above, here the negative was
It's on
out
the
front
outside.
and distributed to everything.
Mhm.
Here it's different. Now whenever there's something going on in here, you have to take what's here and plug it in for every x.
Got
So
it.
that's what we have to do.
Okay. So anytime
You're going to
You
plug
plug
that
that
in
in
for
there
there and
and
there
oh boy,
and
and
there.
there.
So let's do
Okay.
that right now. So g of x.
g of x equals
In
so
parentheses.
negative x
Yep.
cubed
Yep.
plus 5
Negative
negative
x.
x.
Yep.
Oh boy. Negative x
Mhm.
squared
Right.
minus 8 times
Right.
negative x plus 1.
Right. We can do this. So
We
let's
can.
go on the next line.
All right. G of x
Mhm.
equals, well, a negative times itself 3 times would leave me with a negative x, correct?
Cubed.
Oh yeah, cubed.
Mhm.
Plus,
5x squared because that's going
yeah,
to be
because
that's going to change to a
will just change to
positive.
positive.
And then a negative 8 times a negative x is a
Makes a
positive
positive
8x
8x
plus
plus
1. And that should be our answer. So
Mhm.
now, if I go over here and, we got to
Oh,
go like
escape.
this, right?
Yep.
Hit escape and I find my mouse and I go over here and I unlock this for you.
Yes.
Now we're going to go
I got
ahead,
you. Now we're
format,
going to
flip.
it. it
Oh,
didn't
click.
There
There
we
you go.
go.
Format, flip, left and right.
Bam.
Oh,
Oh, it
no.
turned both of them. But that's okay. That's how it would flip.
It was always supposed to turn one of them.
I know.
Oh,
That's
well,
okay.
we'll have to show it in class tomorrow. Okay, so let's go back to full screen.
Okay.
But that's exactly what it's
Full
supposed to do.
Perfect. Okay.
And next, I think we're done with that page. Let's go to example 5. And if I go down here, we're not going to do this one.
No,
We just
we'll
did
do it
one
in
like
class.
that. What is this one? Describe G as,
So
here
that
on
1/2
example,
is-
yeah, what we're doing here is we're creating a new function again.
Right.
And then we're describing it. By describing it, we're writing the rule, and then we could also use words too.
Mhm.
So all we're doing here, this is a compression, a
Mhm.
factor out front.
Right.
So we're just taking 1/2 times the whole
Everything.
function. So let's do that.
So the g of x
Mhm.
would equal 1/2 times, right?
Yep.
2x to the fourth
Right.
minus 6x squared
Correct.
plus 1.
Right. And now we distribute the 1/2.
All right, so then we get half is just x
To
to
the
the fourth
minus
3x squared
plus 1/2.
plus 1/2.
And so all that's, maybe we'll write the word compress,
Sure.
just so they know. It's a compress, not a stretch, because your factor is less than 1. It's a 1/2. And as you can see, when you compress, remember, C, chunky. And so if you look over here, see the F?
Oh, yes, this was our original.
Right. And so we think C, chunky, but on this one, if you want to, it's kind of hard to tell the chunky. Instead, I think of compressing a garbage can. I compress garbage. So the red is being compressed towards the x-axis.
Gotcha.
As you can see it floated up.
Pops up.
Yeah.
Okay.
That's example 6. Example 7, I think what we're going to do on this one is, I think we should maybe hold off. It's a stretch. Let's just do that in class.
Okay.
Example 8. Oh boy. What's, ooh. Look at, I think we better, how many more do we have here?
Boy. There's a lot on this one.
Oh boy.
Okay.
Oh boy. Okay, so what do you think? How long?
Let's do one of them.
Should we do one of them?
Yeah.
Because if we look at this right now and I bring this down, our video is getting,
Oh boy.
oh, we're okay yet.
Yeah.
Okay.
Let's do one and then we'll be done.
Yeah, here we go. Write a function that transforms that function in each of the following ways. I want to do one of these because we're doing two things.
Right.
We're compressing vertically by a factor of 1/3. That's our A.
Yep.
So maybe write A equals 1/3. And we're shifting 2 units to the right, so H is equal to 2. Okay. So now, well, let's see. What are we going to do? First of all,
do the g of x.
I would do, is equal to. So
and this
1/3.
was our original. So now we got to do 1/3 of it.
Out front.
1/3.
And then in parentheses.
6x to the third minus 3.
Okay, we did one part of the problem.
Right.
Close the parentheses. Now remember, when you have a horizontal move, right or left, you're going to substitute inside the x value.
So it's going to come in here.
Right, so you're going to plug in not x plus 2, but x minus 2. Right.
So then we got g of x.
This is where I think we're going to lose a lot of you on this one. But in parentheses, do a 6. And in another parentheses, x minus 2 cubed.
Oh, cubed. Yep, sorry. I forgot. We're not doing our linears anymore.
Minus 3. Close the parenthesis. Okay, now look what we can do. We can distribute the 1/3 only to the 6 and the negative 3. So if we write g of x is equal to 1/3 times 6, that's 2. And keep the parentheses, x minus 2 cubed minus 1. Yikes.
Oh boy.
So if we look over here at the function, that f of x function now was number 1 compressed, which as you can see, it's shifted up towards the x-axis. That's compressing it.
Yep.
And it's moved 2 units to the right. You can see that 1, 2.
Perfect.
And there's the graph. So let's go forward.
So we don't go by
sorry
these.
about that.
Sorry.
Sorry about that. Let me go back. Oh boy. Oh boy. Scroll down.
We don't go by these numbers because this would have been a stretch.
Right.
So we go by our original.
Original.
Okay.
Exactly. Right. I just thought to finish the problem, distribute, you go back through and you go by the original. Exactly. All right then. Let's go forward. We're going to wait and wait because I think they need class time for that.
Lots of practice.
Write the rule for the function. This is a horizontal transformation. This one should be pretty straightforward. And the next one is you're given a function reflected across the x-axis. And remember the rule, you'll back and look at your notes. That just means really the negative is out front.
And then distribute it.
See you tomorrow.
Bye.